Hi, for our project, we are investigating the properties of magnets. Specifically, we are testing the size of magnetic fields. Magnets are powerful and unique rocks or metals that are able to produce a magnetic field around them, similar to how an electric charge creates an electric field in the space around it. To study properties of the magnetic field, we decided to determine the range of the magnetic field for two magnets of varying sizes. For the first method of testing the magnetic field, we balanced hex nuts on top of each other on the lip of a cup. This allowed us to measure and demonstrate the stabilizing capabilities of the magnets. Looking at the pictures, even as the height of the magnets increased with the addition of stacked cards, the magnet was capable of producing a stabilizing magnetic field for up to 0.75 inches. The same procedure was done for a smaller magnet in size. In this picture, there is a visible decline in the range of the magnet, since it required a taller glass for the hex nuts to be closer to the magnet in order to stabilize them. Our second method for measuring the range of the magnets was to tie a string to a hex nut and dangle it below the magnet until the hex nuts collapsed. The same procedure was repeated for the smaller magnet. The video shows a noticeably smaller separation distance that results in the magnetic field having too weak of an attracting force to keep the system of hex nut chains from collapsing. The connected hex nut chain was the final method of measuring the magnetic field. This method demonstrates the extensive stabilizing effect that magnetic fields have when the hex nuts are in contact with the magnet. The final measurements are recorded and organized in the following table. The discrepancy between the first two methods of measuring the range of the magnets can be contributed to the added pressure of balancing the hex nuts on the lip of a cup, as compared to freely dangling the hex nuts under the magnets. By looking at the picture, the field lines extend out from the magnet in the north to south direction. That is, the direction of the field lines run from the north pole to the south pole of the magnet and progressively get larger, but weaker as it expands. This is demonstrated by the consistent thinning of the blue lines as the field extends outward and away from the concentrated pool of the magnets. This explains why magnetic objects experience a less attractive force as they move away from the magnet. When a magnetic object maintains a connection to a magnet, the field lines are able to run through the object and maintain a stronger pull on the object. When the object is not in contact with the magnet and is moved away, as is the case in method 2, using string to find separation distance, the field lines have to pull on the object from further distance, which becomes more difficult with increasing distances. Looking at the field model for the smaller magnet and the measurements summarized in the previous table, there is a clear trend that the size and strength of the produced magnetic fields are proportionate to the size of the magnet. Thank you for watching.